Hello, today our class is on standard deviation. We will see what is standard deviation. First, we will know the meaning of standard deviation. The chief defect of mean deviation is that it ignores algebraic signs of deviations. To remove the drawback of all the methods which we have discussed so far, standard deviation is used. Like mean deviation, the calculation of standard deviation is also based on all the observations. It is a popularly used method. Let us discuss its related measures and computational aspects today in today's class. Okay. Mm, to overcome the limitations of ignoring the algebraic signs in mean deviation, the concept of standard deviation was developed by Karl Pearson in the year 1893. Standard deviation may be defined as the square root of the mean of the squared deviations measured from arithmetic average. Okay, it is also called the root mean square deviation. It is also called as root mean square deviation. Standard deviation is also called as root means square deviation. Symbolically, it is expressed by small Greek letter sigma, call it as small Greek sigma. Um, Large sigma is called as summation. We use big sigma for summation. Small sigma for represent the standard deviation. For calculating the standard deviation, the deviations are always taken from mean. Okay, whereas we used mean, median, mode to take deviations. In the mean deviation, but whereas in case of standard deviation, deviations are always taken from mean, because the sum of squared deviations are minimum when measured from the arithmetic average. Okay, high value of standard deviation denotes greater variation and less uniformity, whereas the lower value indicates greater representativeness of the averages, right? While the standard deviation is an absolute measure, the relative measure is known as coefficient of standard deviation. Standard deviation is an absolute measure, whereas a relative measure is known as coefficient of standard deviation, right? Next, differences between mean deviation and standard deviation. What are the differences between? Okay, though theoretically both the mean deviation and standard deviation are computed by taking all the observation in the distribution, some differences are there. Certain differences are noticed. There, if you see the PPT, you will come to know. Mean deviation and standard. Mean deviations are to be taken by ignoring plus or minus algebraic signs, ignoring the algebraic signs in case of mean deviation, whereas in standard deviations are taken by taking plus or minus signs into account. We will consider the algebraic signs, whereas in case of mean deviation, mean deviation can be computed from any of the three averages, namely we have discussed mean, median, mode. Whereas standard deviation should be always computed from the arithmetic mean only. We don't use positional average, median and mode to compute the standard deviation. Only we use mean. But whereas in mean deviation we use all the three averages, that is mean, median, mode. And third one is the deviations need not be squared in case of mean deviation. Deviations need not be squared, whereas the deviations are to be squared in case of standard deviation. Deviations are squared. In order to remove algebraic signs, we do that, right? Next, calculation of standard deviation. Uh, in order to calculate the standard deviation, for individual, discrete and continuous series, we have different methods, different procedure. First we will see for individual series, procedure for individual series. When deviations are measured from actual arithmetic mean. when deviations are measured from actual arithmetic mean in individual series, first step is calculate the arithmetic mean of the given distribution. Calculate the arithmetic mean of the given distribution. Take the deviations from the actual mean, that is x minus x bar, okay, and square the individual deviations and find out their total. Okay, third is square the individual deviations and find out their total. Fourth is divide the square deviations by the number of items and find out the square root to obtain the standard deviation. Okay, thus formula sigma, okay, small sigma, that is, okay, Greek small sigma, which is equal to standard deviation, which is equal to under root of sigma x square by n, where here sigma means summation of x square by n. Okay, this is big sigma, where small sigma is equal to standard deviation, sigma x square, sum of squared deviations of x values measured, okay, from the actual arithmetic mean. N is the total number of observations, right? And fifth step is for obtaining coefficient of standard deviation, divide the standard deviation by the arithmetic mean, that is x bar. Okay, thus coefficient of standard deviation is equal to small sigma by x bar. Small sigma indicates standard deviation, whereas x bar indicates arithmetic mean, right? We'll take one example. Calculation of standard deviation of individual series by taking actual arithmetic mean. Okay, deviations taken from actual arithmetic mean. He has given x values, hence I, okay, took the red color that is given in the problem. Okay, okay, we need to calculate, only he has given x and asked to find standard deviation from the given data. Okay, he has given x series only. We need to find deviations, that is x minus x bar into small x, we indicate the same with, and we need to square the deviations that we got from the given x series. Here x is given as 22, 17, 15, 23, 25, 24, 16, 18, 26, 14. This total becomes sigma x, that is 200. Okay, whereas x minus x bar, okay, the values of x values are, okay, subtracted, okay, by their arithmetic mean. Okay, here arithmetic mean how much is, there are number of observations are 10 is given, the sigma x 200, 200 by 10 is equal to 20, you will get 20 is nothing but x bar, that is average. If you subtract 20 minus 22 minus 20, okay, if you, from all x's, that means all x series, you will get, for example, first you will get 22 minus 20 2, 17 minus 20 minus 3, 15 minus 20 minus 5, 23 minus 20 plus 3, 25 minus 25, 24 minus 24, 16 minus 20 minus 4, 18 minus 20 minus 2, 26 minus 6, 26, 14 minus 20 minus 6. Okay, you have minuses and pluses, that means you are considering the algebraic signs. Okay, that is plus minus. Then in order to remove these algebraic signs, we need to square these deviations, that is 2 square is nothing but 4, 3 square minus 3 into minus 3 9 plus 9, minus 5 into minus 5 25, that means minus 5 whole square is nothing but 25, 3 whole square is nothing but 9, 5 whole square is 25, 4 whole square is 16, minus 4 is whole square is 16, minus 2 whole square is 4, 6 whole square is 36, minus 6 whole square is 36. The total, the sum of the x squares is equal to 180, that is sigma x square is equal to 180. Okay, then we know that we find the x bar, that is 20, based on those only, that only we calculated the deviations and we squared the deviations. Now we need to substitute the same in the formula. Okay, that is small sigma is equal to under root of x square by n, sigma x square by n, where sigma x square we got sum of the square deviations, that is 180. N is equal to number of observations. There are 10 observations are there. Hence 180 by 10 under root 180 by 10. That is 180 by 10 is nothing but 18. That is square root of under root 18 is equal to 4.24. Now we need to calculate coefficient of standard deviation from this. Okay, you got standard deviation by arithmetic mean, that is 4.24 by am we got is 20. 4.24 by 20 is equal to 0.212. Okay, as the coefficient of standard deviation, okay, is very less, okay, coefficient of standard deviation is less, hence it is more consistent and more uniformity. That means the given data series representative of the population, right? Next, uh, formula for calculation of standard deviation of individual series which are taken from assumed mean. Okay, we have a procedure for this, and according to the procedure, first step is take any value as assumed mean and measure the deviations of x from the assumed mean and find its total. Okay, second, square these deviations and find out their total. Third, apply the formula is given, that is sigma, small sigma, okay, which is nothing but standard deviation, which is called under root of sigma dx square. Here sigma means capital sigma, okay, that is big sigma, that is summation of dx square. That means dx square is nothing but, we will see where these words will be defined below. You see it ppt, if you see it ppt, a small sigma standard deviation is equal to under root sigma dx square by n minus sigma dx by n whole square. This is the formula for calculation of standard deviation from assumed mean for individual series, right? Where sigma dx is equal to sum of deviations measured from assumed mean. Okay, sigma dx square is nothing but sum of the square deviations measured from the assumed mean. N is the total number of observations, right? Now we'll consider one problem for the better understanding of standard deviation and coefficient of standard deviation from assumed mean. We have given X series, that is it contains the values of 458, 459, 450, 448, 457, 462, 439, 454, 451. Now what we need to do, we need dx, deviations from assumed mean. Okay, hence I took 457 as assumed mean and a minus, okay, that is x minus a, that is x value is 458 minus 457 plus 1, 459 minus 457, okay, plus 2, 450 minus 457 minus 7, 458 minus 457, okay, minus 9, 457 minus 457 0, 462 minus 457 plus 5, 439 minus 457 minus 18, 454 minus 457 minus 3, 451 minus 457 minus 6. The sum of these deviations called sigma dx, summation of dx is equal to minus 35. Okay, if you add minuses and pluses, okay, you will get because of minuses are more, they are 35 more, you will get minus 35. Now these deviations, okay, dx square deviations, okay, deviations are squared, hence dx is squared, that is minus plus 1 whole square 1 only, plus 2 whole square 4, minus 7 whole square plus 49, minus 9 whole square 81, 0 whole square 0, plus 5 whole square 25, minus 18 whole square 324, minus 3 whole square 9, minus 6 whole square 36. Okay, you will now you got dx and as well as dx square. Okay, that means sigma dx and sigma dx square, where in the problem we need these two terms, right? Now we will introduce the same in the formula. Arithmetic mean is equal to x bar is equal to sigma x by n. Why we need arithmetic mean here? Because in order to calculate the coefficient of standard deviation we require arithmetic mean. That's why first we need to calculate the arithmetic mean. X bar is equal to sigma x by n. Sigma x, how much you got? Sigma x is 4078. Okay, n is number of observations 9. Then substituting these values in the x bar is equal to sigma x by n, that is 4078 by 9 is equal to 453.11. Now we will consider the formula of standard deviation and introduce the values. That is sigma, small sigma is equal under root of sigma dx square, that is big sigma dx square, summation of dx square by n minus summation of dx by n whole square. Okay, where we know that sigma dx square is equal to 529, sigma dx is equal to minus 35, and number of observations is 9. If you substitute all these values in the given formula, that is under root of 529 by 9 minus 35 by 9 whole square. Okay, under root of 529 by 9 is nothing but 58.78 minus 35 by 9 whole square is equal to, you will get minus 35 by 9 whole square. If you simplify this, that is 15.12. Under root of, if you subtract from 58.78 minus 15.12, you will get under root of 43.66, which is equal to 6.61. Coefficient of standard deviation is equal to small sigma by x bar. That is, small sigma is nothing but standard deviation. Standard deviation value we got is 6.61. 6.61 by x bar value is 453.11. 6.61 by 453.11 is equal to 0.015, which is very low. Okay, hence the coefficient of standard deviation is very low. The distribution is highly consistent. Okay, and it represents the given distribution, right? Next, calculation of standard deviation for discrete series we will consider. Okay, for discrete series, when discrete series and deviations are measured from actual mean or arithmetic mean, we will have a procedure for this, and first we will see the procedure. According to the procedure, first step is calculate the arithmetic mean. Okay, first step is calculate the arithmetic mean. Second is obtain the deviations from mean and square each individual deviation. Third is multiply the squared deviations with the respective frequencies and obtain their total. Okay, next, fourth one, divide the sum of the product. Okay, sum of the product of squared deviations and frequencies by the sum of frequencies and find the square root. Thus, formula is sigma, small sigma is equal under root of sigma fd square. F is the frequency, product of d is nothing but deviations, fd square by n, where sigma fd square, that is sum of the product square deviations are into the frequencies. Sum of the product of squared deviations, we are taking this deviations into consideration and squaring them and multiplying them with the frequencies. That is sum of the products of square deviations and their frequencies. Okay, n is equal to sum of the frequencies, that is we call it as sum of the total of the frequencies. Okay, sum means sum, total. Okay, total, right? Next, fifth step is for obtaining coefficient of standard deviation, divide the standard deviation by arithmetic mean. Thus coefficient of standard deviation is nothing but is equal to small sigma, that is standard deviation, by x bar, that is arithmetic mean. Okay, then you will get this. Okay, in order to know have better understanding on this, we will solve one problem. Example we will consider. Deviations measured from actual mean we will have. He has given bursting pressure of number of samples. Bursting pressure of number of samples is given, that is 10, 12, 14, 16, 18, 20, 22, 24, 26. And he has also given that brand A, that is F, we are considering it as F. Brand A, brand B has given that number of samples, we call it as there in the PPT I has taken because of space only abbreviation NS is written. NS is nothing but number of samples. Okay, number of samples of brand A 2, 3, 2, 4, 1, 8, 3, 1, 2. Okay, brand B is 4, 10, 8, 6, 2, 0, 4, 2, 0. These are the information given by the examiner. We need to calculate Fx and D, okay, and okay, D square and FD square. D square, FD square, right? And same should be calculated for brand A and brand B. Now, if you see Fx, F into X, okay, bursting pressure is X, number of samples are considered as frequency F. Hence, 10 for band A, 10 into 2, 20, 12 into 3, 36, 14 into 2, 28, 16 into 4, 64, 18 into 1, 18, 20 into 8, 160, 22 into 3, 66, 24 into 1, 24, 26 into 2, 52. This will be the X, the product of frequencies and the bursting pressure of the brand A. Okay, which will it is nothing but sigma fx is called. If the sum of these fx, product of frequency and x values, are nothing but sigma fx, which is equal to 468. And now we need to take deviations, x minus x bar. Okay, x bar, how much you will get? Number of observations are 26, and in order to calculate x bar for this discrete series, x bar is equal to sigma fx. Sigma fx is 468 you got. Number of observations 26. Okay, 468 uh, sum of the frequency. N is nothing but sum of the frequency or number. 26. 468 by 26 is equal to 18. X bar here 18. Okay, 10 minus 18. X values, we need to subtract x bar value from x values, that is 18, from each x bursting pressure value, that is 10 minus 18 minus 8, 12 minus 18 minus 6, 14 minus 18 minus 4, 16 minus 18 minus 2, 18 minus 18 0, 20 minus 18 2, 22 minus 18 4, 24 minus 18 6, 26 minus 18 8 you will get. Then these values are squared, these deviations we call it as D. These deviations are squared, okay, in order to remove the algebraic signs. That is minus 8 into minus 8, that is minus 8 whole square is nothing but 64, plus 64 minus 6 whole square is equal to plus 36, minus 4 whole square is equal to 16, minus 2 whole square is equal to 4, 2 whole square is equal to 4, 4 whole square is equal to 16, 6 whole square is 36, 8 whole square is equal to 64 we will get. Now we need to multiply these square deviations with the frequencies, that is number of samples given in the formula. If you multiply 64 into 2, 128, you will get 3 into 36, 108, 2 into 16, 32, 4 into 4, 16, 1 into 0, 0, 8 into 4, 32, 3 into 16, 48, 1 into 36, 36, 2 into 64, 128. If you add all these, it will become sigma fd square, summation of fd square, which is equal to 528. In the same manner, we need to calculate, okay, fx, d and d square, fd square for band B. Here band B, number of samples or f is given, and x is same, that is bursting pressure for brand A and brand B. Hence 10 into 4, 40, 12 into 10, 120, 14 into 8, 112. If you see the PPT, you will come to know all these. Okay, and 16 into 6, 96, 18 into 2, 36, 20 into 0, 0, 22 into 4 88, 24 into 2 48, 26 into 0 0. Now you need to consider sigma. You got fx. If you summate all this, you will get sigma fx. Sigma fx is equal to 540. Number of observations, that is sum of the frequencies, are 36. Hence, to find the arithmetic mean, sigma fx, okay, 530, 540 by 36 is equal to 15. Hence x bar is 15. You need to, okay, subtract from x, that is bursting pressure. 10 minus 15 is equal to minus 5. 12 minus 15 is equal to minus 3. 14 minus 15 is equal to minus 1. 16 minus 15 is equal to 1. 18 minus 15 is equal to 3. 20 minus 15 is equal to 5. 22 minus 15 is equal to 7. 24 minus 15 is equal to 9. 26 minus 15 is equal to 11. If you add all these, okay, if you square all these algebraic signs will be removed. Minus 5 whole square is equal to plus 25, minus 3 whole square is equal to 9, minus 1 is equal to 1, whole square is equal to 1, 1 whole square is equal to 1, 3 whole square is equal to 9, 5 whole square is equal to 25, 7 whole square is equal to 49, and 9 whole square is equal to 81, 11 whole square is equal to 121. Now you need to multiply all these square deviations with their respective frequencies, that is number of samples. 25 into 4 100, 10 into 9 900, 8 into 1 8, 6 into 1 6, 2 into 9 18, 0 into 25 0, and 4 into 49 196, 2 into 81 162, 0 into 121 is equal to 0. If you add all these fd square, product of deviation, square deviations with their respective frequencies, you will get sigma fd square is equal to 1390. Okay, we know that standard deviation is equal to sigma fd square, and okay, sigma fd square by n, sigma fd square is equal to 1390 and n is equal to 36. You will get 6.21 as standard deviation, 6.21. okay, now we need to calculate coefficient of standard deviation from standard deviation and mean, that is small sigma by x bar, that is standard deviation by arithmetic mean. Standard deviation is 6.21 by 15, which is equal to 0.414. right? As if you observe this figure, coefficient of standard deviation of brand A and brand B, okay, brand A paper sample is low when compared with brand B sample. Hence, brand A is considered to be more consistent than the brand B. Right? Now, we need to calculate uh, standard deviation and coefficient of standard deviation for a discrete series. Okay, we have a procedure for this. When deviations are taken from assumed mean, okay, we have already discussed actual mean. Deviations are taken from actual mean. Now we are going to discuss when the deviations are taken from assumed mean. First step is take any value in the distribution as the assumed mean and measure the deviations of x from the assumed mean. Second, multiply the deviations with their respective frequencies and add them. Third, square the deviations and multiply them with respective frequencies and add them. Fourth is apply the formula. Formula is nothing but sigma, small sigma, that is standard deviation is equal to under root sigma fd square by n minus sigma fdx by n whole square. Sigma fdx square by n minus sigma fdx by n whole square, where sigma fds square is equal to sum of the products of standard deviation and frequencies. Sum of the product of standard deviations, or we can say that deviations taken from assumed mean. We can't say standard deviation, deviations taken from assumed mean and frequencies, product of frequencies. Next, sigma fdx is equal to sum of the products of deviations and their respective frequencies. Sum of the products of deviations and their respective frequencies. N is equal to sum of the frequencies. Okay, n is equal to sum of the frequencies. We will see one example for its better understanding, right? Here he has given weight in cases, okay, and number of boys. Weight in cases are, we consider it as x, 40, 42, 44, 46, 48, 50, 52, 54, 56, uh, 58, 60. And number of boys are, that is nothing but f, 12, 8, 4, 10, 5, 9, 5, 3, 2, 1, 1. Okay, what he has given is represented with red color, and what we have solved based on those data which we have solved is taken in black. Okay, we need to calculate dx, okay, from x, and dx square, and we need to multiply the frequencies with deviations, that is dx, and we need to square the multiply the frequency with the squared deviations, okay, that is dx square. You will get sigma f, that is equal to n is equal to, sigma f is nothing but sum of the frequencies, that is which is equal to 60, and sigma f dx is equal to plus 52 minus 2 is 6. If you dx, you will have minus and pluses. If you, okay, that is product of frequencies with the deviations dx, you will get minus 206, okay, minus 206 sigma f dx. Why we require this sigma f dx is because of, in order to find out the arithmetic mean will have sigma f dx by n, right? X bar is equal to a plus sigma f dx by n. We know the principal formula to calculate the uh, x bar. Here a is equal to 50, we know that is assumed mean, and sigma f dx is equal to minus 206, and n is equal to 60. If you substitute all these in these, you will get the x bar value, that is 50 plus minus 206 by 60, which is equal to 50 minus 3.43, which is equal to 46.57. Now we need to calculate standard deviation from the data, that is small sigma, which is equal to under root sigma f dx square by n. We have calculated f dx square by n, we know the n, and sigma f dx also we have calculated, sigma f dx by n whole square. Now where we know that sigma f dx square, okay, which we have calculated from the given data, is equal to 2340, sigma f dx is equal to minus 206, and n is equal to sum of the frequencies, that is equal to 60. Substituting these values in the formula, we will get under root 2340 by 60 minus 206 by 60 whole square. If you look at the PPT, you will understand this, right? When 2340 by 60 is equal to 39 minus 206 by 60 whole square, okay, and whole square after okay, division, you will get 11.76, that is under root 39 minus 11.76 is equal to under root 27.24, okay, under root 27.24 is equal to 5.22 is the answer. Now we got standard deviation, and we need to calculate the coefficient of standard deviation. We got standard deviation as 5.22 by, we know that x bar is equal to 46.57, 5.22 by 46.57 is equal to 0.112. This is nothing but coefficient of standard deviation. Coefficient of standard deviation of the weights is very low, hence the distribution is said to be more consistent, right? Next, computation of standard deviation and coefficient of standard deviation for continuous series from deviations taken from actual mean, that is arithmetic mean. Okay, when the deviations are taken from actual mean, arithmetic mean, the procedure is, first step is find the mid value of the classes of the distribution. First, what we need to do, we need to find the mid values when it is in the continuous form. Second, calculate the arithmetic mean and take the deviation of mid value from the actual mean. Third, square the deviations and multiply them with their respective frequencies and obtain their totals. Fourth, divide the sum of the products of frequencies and squared deviations by the sum of the frequencies and obtain the standard deviation. Symbolically, that is standard deviation, okay, sigma, small sigma is equal to under root sigma fd square by n, okay, where sigma fd square is equal to sum of the products of frequencies and square deviations taken from the mean, okay, n is equal to sum of the frequencies, right? Now we will take one example for better understanding. Okay, here what the examiner has given is taken in red color, and what we need to do is given in the what we have solved, what we have calculated is given in the black color. Okay, he has given class interval, that is 1 5 5 9 9 13 13 17 17 21 21 25, and he has also given frequencies. Now we need to calculate mid values from the given classes. Okay, 1 plus 5 by 2, that is 3. Okay, 6 by 2 is equal to 3. 5 plus 9, 14 by 2 is equal to 7. 9 plus 13, 22 by 2 is equal to 11. 13 plus 17 is equal to 30. 30 by 2 is equal to 15. Okay, these are mid values. 17 plus 21 is equal to 38 by 2 is equal to 19. 21 plus 25 is equal to 46 by 2 is equal to 23. Sigma f, this is the sum of all these, okay, that is mid values is given, and frequencies, if you sum add these frequencies 15 12 20 16 10 2 are given. If you add all these frequencies, you will get sum of the frequency, that is sigma f, or we can say that n, which is equal to 75. And now we need to calculate f x. X is nothing but mid value. F into x, the product of mid value and f, you need to find out, that is sigma fx, the sum of those. 3 into 15 is equal to 45, 7 into 12 84, 11 into 22 20, 15 into 16 240, 19 into 10 190, 23 into 2 46. If you add all these, you will get sigma fx. Sigma fx is equal to 825. Now we need to consider deviations. Okay, in order to make deviations, first we need to find out the arithmetic mean. Okay, x bar is equal to sigma fx by n. Sigma fx, as we know, that 825, n is the number of observation, that is sum of the frequencies, that is 75. 825 by 75 is equal to 11. Hence, okay, 3 minus, okay, mid value minus arithmetic mean, that is 3 minus 11 is equal to minus 8, 7 minus 11 is equal to minus 4, 11 minus 11 is equal to 0, 15 minus 11 is equal to 4, 19 minus 11 is equal to 8, 23 minus 11 is equal to 12. Okay, in such a manner we will get the deviations. Now we need to square all these deviations, that is d square. Minus 8 whole square is equal to 64, minus 4 is whole square is equal to 16, 0 whole square is equal to 0, 4 whole square is equal to 16, 8 whole square is equal to 64, 12 whole square is equal to 144. Okay, arithmetic mean is x bar we have calculated. Now what we need to do, standard deviation we have to find out. Okay, uh, standard deviation. Okay, standard deviation, in order to find out the standard deviation, we need to multiply the frequencies with the deviation, square deviations. The product of frequencies and square deviations is nothing but fd square, which we require for the purpose of calculating standard deviation. Hence d square 64 f 15, 15 into 64 960, 12 into 16 192, 20 into 0 0, 16 into 16 256, 10 into 64 640, 2 into 144 288. If you add all these fd squares, the product of frequencies and deviation square, you will get sigma fd square, which is equal to 2336. Now we substitute the same in the formula. Standard deviation is equal to sigma fds square by n. Sigma fds square, we know that 2336 by n 75. Under root 2336 by 75 is equal to under root 31.15, which is equal to 5.58. Coefficient of standard deviation is equal to small sigma by x bar. Okay, that is small sigma, that means standard deviation is equal to 5.58 by 11, which is equal to 0.507. Okay, as the coefficient of standard deviation is high, that is 50% above, hence the distribution is less uniform and more variable. We can conclude that from the result. Right, now we'll compute standard deviation and coefficient of standard deviation for continuous series when the deviations are taken from assumed mean. We have a procedure for this. According to the procedure, first step, find the mid values of classes of the distribution, and second, take any value from the mid values as the assumed mean and measure the deviations of mid value from the assumed mean. Third, multiply these deviations with the frequencies and obtain the total. Fourth, square the deviations and multiply them with their respective frequencies and find out their total. Use formula, that is sigma is equal to under root sigma fd x square by n minus sigma fdx by n whole square, where sigma fdx is equal to sum of the products of the deviations measured from assumed mean and their respective frequencies, and sigma fd square is equal to sum of the products of squared deviations measured from assumed mean and their respective frequencies. Okay, n is equal to sum of the frequencies. And sixth step is coefficient of standard deviation is obtained by dividing the standard deviation by the arithmetic mean. It is a general formula. It can be shown coefficient of standard deviation is equal to standard deviation by arithmetic mean. Okay, now we will do one problem on this for better understanding. That is, what he has given is, he has given class 12, that is 0, 6, 6, 12, 12, 18, 18, 24, 24, 30, 30, 36, 36, 40, and he has also given frequencies 5, 8, 4, 6, 10, 9, 3 according to the corresponding classes. And we need to find calculation of we need to find out the standard deviation and coefficient of standard deviation. To do this, we need to find out first mid value. Okay, 0 plus 6 by 2 is equal to 3, 6 plus 12 by 18 by 2 is equal to 9, and 12 plus 18, 30 by 2 is equal to 15, 18 plus 24 is equal to 42 by 2 is equal to 21, 24 plus 30 is equal to 54, 54 by 2 is equal to 27, 30 plus 36 is equal to 66, 66 by 2 is equal to 33, 36 plus 40 is equal to 78, 78 by 2 is equal to 39. Now we need to multiply these mid values are considered as x, and x minus a means assumed mean is equal to dx. A I am considering as 21, hence okay, 3 minus 21 is equal to minus 18, 9 minus 21 is equal to minus 12, 15 minus 21 is equal to minus 6, 21 minus 21 is equal to 0, 27 minus 21 is equal to 6, 33 minus 12 is equal to 33 minus 21 is equal to 12, 39 minus 21 is equal to 18. Okay, now you got dx. If you square these values, that means dx square, if you you will get minus 18 whole square is equal to 324, minus 12 whole square is equal to 144, minus 6 whole square is equal to 36, 0 whole square is equal to 0, 6 whole square is equal to 36, 12 whole square is equal to 144, 18 whole square is equal to 324. Okay, now if you multiply the frequencies with their corresponding deviations, then minus 18 into 5 minus 90, minus 12 into 8 minus 96, minus 6 into minus 6 into 4 minus 24, 0 into 6 0, 6 into 10 60, 12 into 9 198, 18 into 3 you will get 54. These are the fdx values. And now fdx square we need to, that means frequencies multiplied with the square deviations, that is dx square 324 and f is 5, 5 into 324 is equal to 1620. 8 into 144 is equal to 1152. 4 into 36 is equal to 144. 6 into 0 is equal to 0. 10 into 60, 10 into 10 into 36 is equal to 360, and 9 into 144 is equal to 1296. 3 into 324 is equal to 972. If you add all these, you will get sigma fd x square is equal to 544. Okay, yeah. Now substitute the same in the formula. Okay, substitute the same in the formula, that is standard deviation is equal to small sigma, okay, under root sigma f dx square by n minus sigma f dx by n whole square, where sigma f dx square is equal to, if you see the ppt, you will come to know that is sigma f dx square is equal to 5544, and sigma f dx is equal to 12, n is equal to 45. Substituting all these values, that is small sigma is equal to under root 5544 by 45 minus 12 by 45 whole square, under root 123.2 minus 0.07, which is equal to under root 123.13 is equal to double one, okay, 11.10. Coefficient of standard deviation is equal to standard deviation sigma by x bar, that is 11.10 by 21.27, that is 0.522. Okay, as the coefficient of standard deviation is 0.522, the distribution is considered less consistent because the value of coefficient of standard deviation is high, right? uh, okay, now uh, we will use step deviation method to calculate um, standard deviation and coefficient of standard deviation for continuous series. According to step deviation mention, okay, deviations are divided by a common factor to make the calculation easier. Okay, calculation of standard deviation under this method involves the correction, that is d dash is equal to m minus a by c. M is mid value and minus a assumed mean. C is a common factor. Here the deviations taken from mid value are divided by the common factor, right? Normally the class interval is taken as the common factor. Generally common factor is class interval, that is lower limit minus upper limit, right? uh, okay, here mid value uh, is we have taken 25 plus 35, that is 60 by 2 is equal to 30. 35 plus 45 is 80 by 2 is equal to 40. 45 plus 55 is equal to 100. 100 by 2 is equal to 50. 55 by 60, 55 plus 65 is equal to 120 by 2 is equal to 60. 65 plus 75 is equal to 140 by 2 is equal to 70. 75 plus 85 is equal to 160 by 2 is equal to 80. These are the mid values. Okay, these multiplied with frequency you will get, that is m minus a by c. Okay, mid value minus assumed mean by common factor. A is equal to 50. Okay, a is equal to 50, assumed mean is 50, and a common factor we have taken is 10. Okay, m minus a, m mid value minus a, okay, that is assumed mean. Okay, mm, mid value minus assumed mean by common factor. Mid value is 30 minus assumed mean is equal to 50. 30 minus 50 is equal to minus 20, by common factor is 10, hence you will get minus 2. If you see the ppt you will come to know. Okay, then 40 minus 50 is equal to minus 10 by 10 is equal to minus 1. 50 by 50, okay, 50 minus 50, 0 by 50, 0 by anything is 0. Then 60 minus 50 by 10 by 10 is equal to 1. 70 minus 50 is equal to 20 by 10 is equal to 80 minus 50 is equal to 30 by 10 is equal to 3. Then d1 square, that is minus 2 whole square is equal to 4, minus 1 whole square is equal to 1, 0 whole square is equal to 0, 1 whole square is equal to 1, 2 whole square is equal to 4, 3 whole square is equal to 9. Now you need to multiply these deviations. Okay, deviations and deviation squares with the frequency. When we multiply the deviations with the frequency, you will get 10 into minus 2 minus 20 minus 15, 15 into minus 1 minus 15, 20 into 0 0, 21 into 1 21, 18 into 2, that is 36, and 16 into 3 48. Whereas if you multiply the frequencies 10 into dx d square d1 square, will fd1 square, that is 10 into 4 40, 15 into 1 1, 20 into 0 0, 21 into 1 21, 18 into 4 72, 16 into 9, you will get 144. If you add all these, you will get sigma fd1 square. Okay, we can say fd dash square where we consider the step deviation method, common factors we take, there we will call it as dash. Okay, sigma fd dash square, that is 291, sigma fd dash 70, and some of the frequencies that we know is 100. Now we need to add all this. Okay, if you substitute in the formula, standard deviation formula, small sigma is equal to, that is sigma under root sigma fd dash square by n minus sigma fd dash by n whole square into c. Sigma fd dash square is equal to 291, sigma fd dash is equal to 70, n is equal to 100, c is equal to 10. We know that. Substituting in the formula, sigma is equal to, okay, small sigma is equal to under root 291 by 100, that is 2.91, minus 70 by 100 whole square, that is 0.49. This is under root into 10. Okay, 7.91 minus 0.49. Okay, under root is equal under root 2.42 into 10. Under root 2.42 is equal to 1.5556. Okay, into 10, which is equal to 15.56. Coefficient of standard deviation is equal to small sigma by x, that is standard deviation by x bar, that is arithmetic mean. Coefficient of standard deviation is equal to, if you substitute the values, that is 15.56 by 57, you will get 0.273. Okay, which is least. As the coefficient of standard deviation is low, the distribution is said to be consistent, right? With this we have completed the standard deviation chapter. Okay, tomorrow we'll discuss another one, right? Thank you.